Yeah, so good evening, students. I hope you can hear me. Okay, because I am watching the live in my mobile to read your comments. So, okay, yeah, I think you can hear me. Correct. So, fine. So, we have finished the third module successfully, the theoretical third module, basically this hydrostatic forces. So, now we'll attempt to solve some problems on the same topic, hydrostatic forces. Okay, hydrostatic forces on plane surfaces as well as curved surfaces. We have seen enough theory for past few days. Then we'll solve problems. So, straight away, let's go for the first problem. This was a question from Gate Mechanical 2020. So, please try to solve this. Okay, so yes. So, please try to solve these questions, students. So read carefully. The barrier shown between two water tanks of unit width, one means basically unit width means there is 1 meter width into the plane of the screen, is modeled as a cantilever. So basically, if this is cantilever, means if this is your barrier which you are seeing here, this is your barrier, then this barrier is modeled as a cantilever. It's clearly given. It's modeled as a cantilever. So from your strength of metals basics, you know what is a cantilever beam. Basically, a beam which is fixed at one end and left free at the other end. Of course, it's not a fobbed cantilever or something. So it's just a cantilever. So this is how the barrier is modeled as a cantilever. Okay. So once this is modeled as a cantilever, then there is a water column of height 4 meters to the left of this barrier, and also there is a water column of height 1 meter to the right of this barrier. Okay, so whenever we have two different fluid levels on both sides of the barrier, then definitely there will be some force imbalance on either side of the barrier. Correct. So now see what he is asking for. Take the density of water as 1000 kg per meter cube. So the density of water is 1000 kg per meter cube, and the acceleration due to gravity is 10 meters per second square. So let us sort out some important data that's given in the question. So basically, width of the plate to the plane into the plane of the screen is 1 meter, because it's clearly given two water tanks of unit width 1 meter. Okay, so this is cantilever. Then density of the fluid which is surrounded is 1000 kg per meter cube. Then acceleration due to gravity is 10 meters per second square. So you can see clearly the acceleration due to gravity, G is equal to 10 meters per second square. Then the maximum absolute bending moment developed in the cantilever is dash kilonewton meter. You need to make a look at the units for NET questions, because many times they'll ask you the answer in different units or in separate units, but of course you generally write it in Newton meters or something. So you need to very carefully look these units whenever you are trying to attempt numerical answer type questions. Okay, so it's kilonewton meter. So now the left side, it's the left side there is a fluid column of height 4 meters, and on the right side there is a fluid column of height 1 meter. Now whenever there is some fluid column, and if this plate is vertical, means this is a barrier which is of a very thin thickness, and of course into the plane or into the screen the depth is 1 meter. Correct. So definitely there will be some hydrostatic force which will be acting here. Okay, so let me take this. So there will be some hydrostatic force which will be acting on the left face of this. Correct. So this is F, which means the force towards right. Okay, similarly let us suppose, because of this water column, 1 meter water column, let us suppose there is some fluid pressure force which is acting, and it should be a bit low in general. Okay, so this is FL. So because of this right side water tank. Now please tell me, what are the expressions for this FR? FR is equal to, look, this plate is inclined at an angle of 90 degrees with this face surface, correct? And the length to which it is to which this is immersed in water is 4 meters. So if you know the hydrostatic force acting on a plane surface, the total hydrostatic force acting on a plane surface is rho G A H bar. You know this, correct? So which means here in case of this, density is 10 cube into acceleration due to gravity is again taken as 10 into area of this contact of this barrier and water phase on the left side. Look, this height is 4 meters and the barrier is into a depth of 1 meter into the scale. So what is the total area that's in contact with the fluid? So totally we have 4 into 1, and of course into this h bar. Now what is the formula for this h bar? This plate is of height 4 meters. So definitely the centroid is somewhere here. So this defense or this height, which you can say here, this height basically. So this height, it will be 2 meters. Correct? So if this height is 2 meters, then h bar is equal to 2 meters, which means you have 2 4s are 8, 8 into 10, 80 kilonewtons is the force that's acting towards right. Okay. Similarly, if you calculate FL, what will be your FL? Similarly, if this is 1 meter height fluid column, then rho G A into h bar again. So this is equal to 10 cube into acceleration due to gravity is 10 area. what is the area of barrier that's in contact with the fluid on the right side? This height is 1 meter and this barrier is into a width of 1 meter unit width, correct? So definitely 1 into 1 into h bar. So for this particular portion, the centroid lies somewhere here. So this distance will be 1 by 2 because the total is 1. So this is 1 by 2. So when this is 1 by 2, we have this. So which means this is 5 kilonewtons, correct? So this is 5 kilonewtons. Now see this cantilever carefully. We know the fluid of pressure force on the left side means pointing towards right is 80 kilonewtons, and similarly the fluid pressure force on the right side fluid because of the right side fluid on this barrier is 5 kilonewtons, correct? So now they are asking you for the maximum absolute bending moment developed in the cantilever. And you know, in case of cantilevers, when it's subjected to point loads and all, the maximum bending moment will be located at this point. So if you take the moments of these forces at this point, that's it, you will get the answer. But for knowing that, you need to know one thing. Look, let me try to analyze the situation for you. Let me take a different color. So yes. So this is your barrier. Okay. So now, this is a force which is acting at some elevation, at some distance from the free surface, and also this is some other force which is also acting from the free surface, correct? So this force we have calculated, this is 80 kilonewtons, and of course this force we have calculated, this is just 5 kilonewtons, correct? This is what we have seen. Now this height is 4, so if you calculate center of pressure for this force, if you calculate the center of pressure means the depth of this center of pressure means if I call this as HP star for the left side fluid, then what is this HP star for the left side fluid? Look, HP star for the 80 kilonewton force, this is equal to, look, this H bar is at a distance of 2 meters from the top because this is the centroid of this 4 meters depth. So 2 plus IXX. Now what is the plane about which you need to take the moment of inertia? So if you project this plane, you will be getting some, plane which is perpendicular to the skin. So this axis which is passing to the centroid will come here, correct? So 4 into, okay, so let us suppose base is 1 into 4 cube by 12, BD cube by 12 into sine square theta. The plate is vertical divided by A H bar. So A is 4 into 1, and what about H bar? We have 2. Okay, so if you cancel out few things, this will be 16. Then 4 table cancels this 3 times and it's 4 times. So this will be 2 again. So this is totally 8 by 3 meters, correct? So this is totally 8 because 2 plus 2 by 3. So 2 3 are 6 plus 2, 8 by 3. So basically this is at a depth of, if this is the free surface, means if in general, if this is the free surface of water on the left hand side at least, then this depth is how much? It's calculated 8 by 3 meters. But this total length is 4. So what is this length about this moment arm? So for example, if you are taking moments about this point, then this distance basically, this distance, okay, this value, okay, so how much is this? 4 minus 8 by 3. 4 minus 8 by 3 is nothing but 4 by 3 meters, correct? So this is 4 by 3 meters. Similarly, what about the case here? Here, this is the water level up to which we have water on the right side. So this height is 1 meter, correct? So this height is 1 meter. So similarly, if you calculate this center of pressure distance from, basically if you try to calculate this distance, which is the depth of center of pressure on the right side, then HP star of this 5 kilonewton force, this is equal to, look, the centroid will be located at half 1 by 2 meter. So 1 by 2 plus IXX. Now this is 1 meter, means basically this height is 1 meter and the thickness into the plane of the board is also 1 meter. So B D cube by 12 and it's vertical. So 1 divided by A into H bar. A into H bar, which is 1 by 2. Correct? This is what we have. So if we cancel a few things, there is 1 by 6. So 1 by 2 plus 1 by 6, which is 4 by 6. Correct? So this is 3 by 6 plus 1. So 4 by 6, which is 2/3 meters. Correct? So this is 2/3 meters. So if this height is 2 by 3 meters, then we have this length or this height as 1/3 meters. Correct? So now they are asking you for the maximum bending moment at this cantilever. So the maximum bending moment is always at the fixed support. So definitely if you calculate the bending moment on this cantilever because of these two forces about this point, then M max, and of course let us suppose if I take the clockwise as positive, so M max bending moment in the positive direction is equal to, look, this creates a positive rotation about this hinge. So 80 kilonewtons into the distance between this force and this hinge is 4 by 3. So 80 into 4 by 3, and this creates an anti-clockwise sense moment. This 5 kilonewtons creates an anti-clockwise sense moment about this hinge. So minus, because clockwise we are taking positive, so anti-clock will be definitely negative. So minus 5 kilonewtons into, and the distance between this moment and this force, means this hinge and this force, is nothing but 1 by 3. So 4 8 is 320 minus 5 divided by 3. This is what we have. So this is 315 divided by 3. So if you simplify a bit, 105, because 315 divided by 3 is 105. This is 105. So 105 kilonewton meter, because we are measuring the units, means the distance in meters, and the force we have measured in kilonewtons. So this is 105 kilonewton meter. Okay, so magnitude of the bending, maximum bending moment. Of course, they asked you for the magnitude, because if you assumed that anti-clockwise is positive, then you could have got minus 105 kilonewton meter. But here we are intending towards the maximum absolute. This word absolute gives you, they are asking you for the magnitude. So the answer is 105 kilonewton meter. Okay, so are you all clear with this? This is a question that's, requires knowledge of both strength of materials a bit as well as your fluid mechanics. So are you all clear till this point? Actually, the answer of this is 105 kilonewton meter, which is given as the official correct answer in GATE. Okay, so are you all clear? Just, it's a very simple question. Just you need to find two forces which are acting because of these fluid columns, and also you need to find the locations at which they are acting. So if you know the forces and if you know the locations at which they are acting from this fixed support, look, if this is the fixed support actually which you are having here, so the moment about this fixed support is something like this. It's a simple moment that you will calculate all the time. So 105 kilonewton meter. So are you all clear till here? So are you all clear till here? So please do respond. Please do type in the chat box. So please do type in the chat box. Are you all clear till this point? If you are clear till this point, clear with this question, then we will go for next question. Clear? Very good. Now let's go for the next question. So there is one next question. So please try to see this. Consider, it's a question from 2016 mechanical basically. Consider a frictionless, massless, let us identify this term. So there is frictionless and one massless and one leak-proof blocking a rectangular hole of dimensions 2r by L. So basically this side is 2r, means this length if you are talking about, this is 2r because it's a semicircular disc, so it's r. So this total length is 2r. Okay, by L. Of course, in the side view, this gate is to a length of L, which you can see here. This is a gate of length L at the bottom of the plate, at the bottom of an open tank, as shown in the figure. So there is one open tank, which means this end is the free surface and it's supposed to be atmosphere. Okay, and similarly here also there is some atmospheric pressure. So let us write the net pressures at the bottom of an open tank, as shown in the figure. The head of the plug has the shape of a semi-cylinder of radius r. So this head of this plug is of a semi-cylindrical shape with a length r. Okay, then the tank is filled with a liquid of density rho up to the tip of the plug. So till this tip of the plug there is some fluid which is filled here. The gravitational acceleration is g. Neglect the effect of the atmospheric pressure. Okay, this sentence has to be made a note. Neglect the effect of this atmospheric pressure. Fine. The force F required to hold the plug in its position is, means basically different, whenever this gate is on this, whenever some fluid is surrounding on this gate, definitely the net horizontal force is 0, but there will be some net pushing by this fluid on this gate, right? So this gate experiences a net downward force because of the surrounding fluid for this length L. Now, in order to withstand the plug, definitely when there is some fluid which is trying to exert some downward force on this plug, definitely you require some upward force which is resisting this downward force of the fluid, correct? And of course, for the plug to be stationary, this resisting force should be equal or greater than, in the limiting case, it should be equal to the pressure force of this fluid, correct? So if you want to identify F, the force F required to hold the plug in its position, in the limiting case, this force F should be equal to the fluid pressure, correct? So now, if you see, I told you clearly, if this is your fluid, fine. If this is your fluid, look, this is some gate. Okay, this is gate. This is gate here. Now, what is the force exerted by this fluid on this surface? Okay, so let us see here. This is, yes, the gate is some, or the plug is something like this. So now see here. If you see this gate as two portions, this is the first portion. Look, let me draw this. So if this is half portion of the gate, and if this is another half, plug. If this is half portion of the plug and if this is half portion of the plug, then the force exerted by this fluid on this portion, left portion of the plug, means basically this portion which I am trying to draw here. This is equal to the weight of this fluid column. Which fluid column? Which fluid column? This fluid column. Correct? The weight is equal to this fluid column weight. The total vertical force on this plug is equal to weight of this fluid column. Correct? Similarly, for the right hand side, the total downward force on this plug is equal to the weight of, yes, so the weight of this fluid column. So totally this fluid column weight is supported by this plug. Okay, so this is what I told you. Now this is to a distance of L into the plane of the board. That's what in the side view you can see. This is the front view. So if this front view is drawn in the side view, this gate is, or this plug is of length capital L, which you can see here. So if you want to know what is the weight of the liquid above this plug, then we need to identify what is this area. Look carefully. Let us try to identify this. If this total is 2r length, because this is radius r, so this will be total 2r. Correct? So and what is the height of this liquid? That should be given. This is given to a height of r. It's clearly given. This fluid is to a height of r, and also it's mentioned in the question that the fluid is filled such that the fluid layer, the free surface just touches the tip of the fluid. You can see clearly the tank is filled with a liquid of density rho up to the tip of the plug. So if the plug is of semi-cylindrical shape, then if this is of radius r, definitely the height of the fluid column will also be r. Correct? Now see here, this height is r again. So what is this total area of this rectangle? This is 2r square. Correct? So 2r square minus area of this semicircle. Area of this semicircle will be how much? Which is of radius r. So this is pi r square by 2. This is the total area of this cross section which is having fluid. Correct? So into the length, this is protruding out to a length L. So because you can see there is a length of L of this plug. So this is the total volume of the fluid which is lying on the top of this plug. Correct? So if this is the total volume of the fluid, so if you multiply the volume with density of the fluid into gravity, acceleration due to gravity, this is the total weight of the fluid which is supported upon by this plug. Correct? So are you all clear till here? So please respond. Are you all clear? How did I get this expression? Basically, this is the area of the fluid which is in this cross section above this plug. So and this plug is of length L. So definitely this cross section multiplied by L will give you the total volume of the fluid, and this volume multiplied by density gives you the mass of the fluid which is present above this plug, and this mass of the fluid multiplied by acceleration due to gravity gives the total weight of the fluid which is supported by this plug. So are you all clear? Yes, rho GV. So basically, so are you all clear till this point? Yes, so please do type in the chat box. Are you all clear with that expression? How did I write this? So this is the F vertical force on this plug. Correct? F vertical force on this plug. Rho F G into 2r square minus pi r square by 2 into L. So are you all clear till this point? If you are clear, please do type in the chat box. Yes, I need responses from all of you whoever is on live. So please do type. Okay, so if that's clear, then this is equal to, if you simplify this expression a bit, you can maybe take r square, because in all the terms there is r square, so you can take out r square, and you can see there is some 2 also in some options. So let us take this 2r square common. Okay, so 2r square, if I take common, this rho GL, it's as it is, into inside if I take 2r square common, I'll have 1 minus pi by 4. Okay, because 2r square I'm taking common, so definitely there should be pi by 4. It's a just mathematical calculation. So 2r square rho GL into 1 minus pi by 4, which you can see here. Yes, 2 rho r square GL, 2 r square rho GL, both are same, into 1 minus pi by 4. Okay. What about weight of air? Because look here, neglect the effect of atmospheric pressure. It's clearly given. Okay, so that's the reason why we are not considering air weight here. Correct? Okay, so in the it's clearly given, neglect the effect of the atmospheric pressure. Okay, so that's the reason why we are not considering air in this analysis. Clear? So are you all clear with this question? If you are clear, then we'll go for the next part. Okay. Fine. Okay, good. Look here. Next, let's go for the next question. A hinged gate of length 5 meters. This is a question from Mechanical 2013. So see here, a hinged gate of length 5 meters inclined at 30 degrees. I'm sorry, this is not degrees Celsius. This is 30 degrees. Okay. So a hinged gate of length 5 meters inclined at 30 degrees to the horizontal and with water mass on its left. Okay, is shown in the figure below. Okay. So there is one gate which you can see here, which is also hinged at this location, and the length of this gate is 5 meters, and this gate is inclined at 30 degrees with the horizontal. Okay, density of water is 1000 kg per meter cube, so this density of this fluid is 10 cube kg per meter cube. Then the minimum mass of the gate in kg per unit width perpendicular to the plane of paper. Okay, so basically if this is the gate, this gate has some width which is equal to the length of my palm. So definitely if this is the gate, then per unit width perpendicular to the plane of paper, what is the mass of this gate? It's obvious, because whenever there is some gate and if the fluid is located in this point, then definitely yes. So you are understanding the things. Good. So see here, look, if this is the gate, then when there is some fluid here, definitely this fluid will exert some force on this gate, correct? And because of that force, this gate will try to rise. So to avoid this counter effect of this pressure force, this gate should have sufficient mass or sufficient weight. So whenever the mass of the gate and this hydrostatic pressure force both are same, this gate rests in equilibrium, closing this water not to go out, correct? So now to have this balance, look here. Let us suppose this is the gate of length 5 meters. Now see carefully. If this is your hinge, if this plate has to be, or this gate has to be in equilibrium, definitely this weight of the gate acts here, W. Okay, and let us suppose, let me extend this column to a bit. Okay, so let us suppose if this angle is theta. If this angle is theta, okay. Now if this is theta, then definitely this will be 90 minus theta, correct? Because if the angle of this line with horizontal is theta, then the angle made by this line with the vertical is W, definitely. So now see here, if this is W, then we can resolve this into two components basically. Look here, this component will be, this is 90 minus theta, so this is W cos 90 minus theta, which is W sin theta, okay? This is W sin theta, and there will be one component which is acting perpendicular to this plate. Let me fine. So if this is something perpendicular, look, then this value is W cos theta, correct? Now this is weight of the plate, which this is the basically the components how they act. Or else let me draw this with a dotted line to avoid this ambiguity. So see here, fine, this is your W cos theta, W cos theta, because the other component is W sin theta, because basically just we resolve this W into W cos theta and W sin theta. Now because of this fluid, definitely there exists some pressure force on this gate, correct? So there exists some pressure force because of this fluid. Now what is the height at which this pressure force acts? Look, definitely if the centroid is somewhere here, and if the centroid is somewhere here, definitely this pressure force will be below the centroid. Why? Because as you go into depth into the water, the pressure increases, and majority of the pressure force is located at a depth which is below much below than this center of pressure, center of gravity. Okay, so if this is your centroid of the plate, then definitely the center of pressure will definitely lie below this centroid, which we have seen in all these classes, theoretical classes, correct? So I want to know what is the total pressure force that is acting. F is equal to rho g a h bar. Look, this is 30, and if this is the plate of length 5 meters, then this length which is still here, this length is 2.5 meters. So see carefully, this is 2.5 meters and this angle is 30. So can I easily identify what is this height, vertical height of this center of depth, or basically this vertical height of this centroid? So if I identify that, F is equal to rho G. Did they give you anything to take assumption? Okay, they didn't mention anything. So 9.81 into rho G A, which is 5 into, it's given unit width per unit width. So if the width of the plate is 1 unit and if the length is 5 meters, then the area in contact with the fluid is 5 into 1 into h bar. H bar is nothing but this is 2.5 and this is 30. So this side, this vertical side will be 2.5 sin 30, correct? So if this is 2.5 sin 30, so this is 1.25. So 1.25. So these many newtons. So let us see what is the value. 5 into 1.25 is 6.25 basically. 6.25 into 9.81 into 10 cube. Okay, someone is having doubt. So how 90 minus theta? Look, if I extend this W and if I join here, this will be one triangle and this angle is 90. Or else you can also observe the angle between this line and this horizontal is theta. So definitely the angle between this line and this vertical will be 90 minus theta. Okay, so that's the reason. Next, let us calculate this value using our calculator, virtual calculator. Okay, so let us open a virtual calculator quickly. Let us open some virtual calculator quickly. It's not here. So see, let us try to open this. Okay, gate, gate calculator, fine. So scientific calculator here. Good. This is the calculator that we need. Now 9.81 into 5 into 1.25. Look, 9.81 into 5 into 1.25 into 1000, of course. So this is the total mass. So 61.312 kilonewtons. So 61.3125 kilonewtons. This is what the total pressure force which is acting. And this pressure force will be acting perpendicular to this plate, because we know pressure is always normal. So if this is the net pressure force, that is always normal to the plate. So basically there is some pressure force which is acting normal to this. Okay, so this force is F. Okay, now we should know what is the height at which it's acting. Okay, so depth of center of pressure, HP star. This is always equal to H bar, which is H bar just now we have found. This is 1.25 plus Ixx sin square theta. Look, sin theta is same as sin 180 minus theta, correct? So even if this is 150 or 30, the values remain same. So Ixx, basically this is a plate of 5 meters length and width 1 meter. So if you apply the moment of inertia about its centroid, 1 into 5 cube BD cube by 12, basically it's a rectangular plate. So into 1 divided by AH bar. So what is this area? 5 into 1 into H bar. So H bar is again 1.25. So this is the depth of center of pressure at which this acts. So see here, if you make calculations here, this is 25. So 25 divided by 12 into 1.25. Let us make this calculation. So 25 divided by 12 into 1.25. Okay, so if you make this calculation, you get 1.666 again. So this value is 1.25. So if you add 1.25 to that, so if you add 1.25 to this, then we get 2.9166 and so on. Okay, so this value is, I think the calculations are correct. So 1 into 5 cube by 12 into 1. Okay, I'm sorry here, I can't substitute 1 because it's not a vertical plate. So it's inclined at some angle 120 degrees. So sin square 120 is same as sin square 30. So sin 30 is 1 by 2. So we need to have 1 by 4 here. Correct? So we need to have some 1 by 4 here in the calculation. So these are the things that make us a bit wrong calculation. So 25 divided by 48 into 1.25. Look, 25 divided by 48 into 1.25. This is what we have. So total 0.4166 plus, let us add 1.25 to this. So if you add 1.25 to this is 1.667. So this value is 1.667. Let us round off to 3 decimals in general. So 1.667 meters, which means this height is 1.667 meters. So if this total center of pressure is 1.667 meters, and obviously it will be more than 1.25 because center of pressure always lies at a location below this centroid. So if this height is 1.667, then what about this length? This is sin 30, so this will be double of this, correct? So which means this force acts at a distance of double this 1.667. So double this 1.667 is basically, if you multiply this with 2, then you have 3.33. So 3.333 meters along this curve, and this length is totally 5 meters. Now, if you see, there are total 3 forces which are acting. This W cos theta, this W sin theta, and this F. Because this W cos theta and W sin theta are the effect of this resolution of W, correct? So now, out of this W sin theta passes through the moment arm. So what are the net forces? Means for the gate to be in equilibrium, definitely what should happen? This W cos theta into this length, and definitely this is the centroid at which this acts. So if it's a plate, so definitely this length will be 2.5. So this into 2.5 is equal to the total pressure force which is acting, which you can see here, 61.3125 kilonewtons into 10 cube. Of course, kilonewtons means 10 cube into this length at which this is acting, which is 3.333. Correct? So this is what we need, but I think they are asking you for mass of the gate. Okay, so if they are asking you for mass of the gate, definitely you need to divide this with acceleration due to gravity. So this W can be written as mass into acceleration due to gravity, and cos theta. So theta value is 30. That's what we have seen. Basically, this is the theta we have assumed in this case. So theta is 30. So m into root 3 by 2, because cos 30 into 9.81 into 2.5. This value should be equal to 61.3125 into 10 cube into 0.333. 3.333. So from this you need to identify what is the mass of the plate, mass of the gate in kgs. Okay, so if you make this calculation a bit quickly, so 61 point, okay, this value into 61.3125, 61.3125, okay, into 10 cube, so into 1000. this value divided by, look, we need to divide it with something, 9.81 into 2.5 into square root of 3. So 9.81 into 2.5 into square root of 3. So into 2.5 into square root of 3. This is the value into 2 because there is root 3 by 2 on this side. So this 2 gets multiplied. So the total mass is, how much did we get? 9622.5. So 9622.5 kgs is the mass of the gate per unit width to withstand this hydrostatic force. So 9622.5. So yes, 9623, option D is the correct answer. Okay. So yes, it's officially also it's given answer D. So we have this 9623 kgs is the mass of the gate per unit width into the tank that should be present to withstand this fluid pressure basically. So are you all clear with this? It's a simple question again. It's basically a mechanics question, but of course it requires a knowledge of fluid mechanics. Clear? Okay. Fine. Are you all clear with this? So please do type in the chat box. Are you all clear with this? Clear? Very good. So the mass of the plate per unit width is 9623 kgs. Okay. And they are asking the same thing. So 9622.5 is what we got. So as per the given options, you can choose 0.5 kgs. And this is the answer, of course. So 9623 is the correct answer. Good. Let's go for this next question. So see here something they are asking you. The horizontal and vertical hydrostatic forces Fx and Fy on the semicircular gate. Look, this is a semicircular gate. Okay, so this is a semicircular gate. The horizontal and vertical hydrostatic forces Fx and Fy on the semicircular gate having a width W into the plane of the figure. So basically, whenever this gate is having some width into the plane of the figure, means basically this gate is extruding out of to a width of W. Then what are the effective hydrostatic forces Fx and Fy? I told you clearly, whenever there is a curved surface, the net force in the horizontal direction is nothing but rho g into area of this curved projection onto a plane which is perpendicular to this x-axis, correct? So if you are looking for a horizontal force, means basically if you are looking for this Fx, then this plane projected onto a horizontal projected onto a plane that is perpendicular to x-axis. So if this is x-axis, then if you project this semicircle onto a plane which is perpendicular to this x-axis, definitely you will get some rectangle, correct? And the height of this rectangle will be, this is basically 2r. So the height of this will be 2r and width will be w, which is into the plane of paper. So this will be width. So this is yes. So basically this is the width. So the area of that is 2r into w because the projected area is 2r into w. Okay, 2r into w, because if you project this semicircle onto a horizontal plane onto a plane which is perpendicular to x-axis, then you will get a rectangle whose side is 2r. Means basically if you project this circle, you will get a line of height 2r and this is of width w. So w, I have done it in the side view. So w into 2r is the total basically this area in contact. So rho g a into h bar. H bar is again the centroid of this projected area. So the centroid of this projected area from the free surface, it's given here. This is h. So into h. This is what you have. So total net force in the x direction Fx is equal to rho g. Okay, two letters right in the first, 2 rho g r w h. Did we have this somewhere? Yes. Okay, we have the formulas down there. So 2 rho g h r w. Okay, r w h or h r w, and here they have mentioned small r's. Okay, so let us put small r's. No issue. They are using small r, so let us put small r only. 2r. So this rho g is taken. So r w h. Okay, that's what we have. So first option is wrong definitely, because Fx is equal in all other three cases, and definitely this option is also wrong because there will be some net hydrostatic force on this. Net hydrostatic force in the y direction, means basically in the vertical direction, because pressure along this interface is not same as pressure along this interface. Now see clearly, this is the area of the fluid. Look, let us try to observe. This is the area which is not fluid, correct? Means this area is occupied by this gate. So if I want the vertical force, this Fv is nothing but area replaced by the gate. So what is this area? It's half of the circle. So pi r square by 2 into, then thickness, means the width of this gate is w out. So w into rho g. So this is basically the vertical force, net vertical force acting on this plate, because you'll see on the top section means basically towards this section, towards this portion the weight will be in the downward direction, and in this portion the weight will be in the, or the fluid pressure force will be in the upward direction, means the vertical component will act upward, correct? So if you apply the balance like total net effective force, that's equal to this cross section means this area into width of the plate. Normally, you know, later stages when you see that there is some body involved here, then the buoyancy force is equal to, of course in the fourth module you will see the buoyancy force is equal to density into gravity into volume displaced by the fluid, correct? Sorry, volume displaced by the solid, correct? So now, as of now, we have this curved surface. So this curved surface will give you a pressure force which is equal to this. Okay, so this is equal to, if you simplify the expressions, pi r square W rho g by 2. This is what we have, and this is somewhere here. Yes, pi rho g W r square, pi rho g W r square by 2. Yes, so D is the correct answer. So are you all clear with this? Yes, gate is semicircle. It's clearly given, you know, semicircular gate, on the semicircular gate. Okay, so that's the reason. Clear to all of you? So are you all clear with this? If you are okay, then we'll go for the next part. Next question basically. Clear? Okay. Fine. Then let us go for the next question. So this is our next question. A triangular gate with a base width of 2 meters and height of 1 meter lies in a vertical plane. Okay, so the gate plate is, so the triangular gate is vertical. Let us try to identify some data from this. So this is a triangular gate, basically base width of 2 meters and height of 1 meter lies in a vertical plane. So this plate is lying in a vertical plane. Okay, so now the top vertex of the gate is 1.5 meters below the surface of the tank, which contains oil of specific gravity 0.8. Considering the density of water and acceleration due to gravity to be 1000 kg per meter cube is the density and 9.81 meters per second square respectively, the hydrostatic force in kilonewtons exerted by the oil on the gate. Look, there is some oil and we have one triangular plate. Fine. Let us suppose this is your triangular plate. Okay. Now, see carefully what they are asking. This plane is vertically immersed in this fluid. Now, when this plate is vertically immersed in this fluid, look, he has given few things. This base is how much? This is 2 meters, correct? It's given base width of 2 meters. So this base is of, you know, 2 meters width in general. Okay, and this height of the fluid, this height of this plate is 1.5 meters. If this is 1.5 meters, okay, this is fine. If this is 1.5 meters, okay, then the top vertex of the gate is 1.5 meters below the surface of the tank. So look here. Let us suppose if we draw some extra expense of fluid, because I just want to show the diagram to the scale at least. So if this is 1.5, it's also clearly given the top vertex. The top vertex, what's the meaning of top vertex? This one, the top vertex. The top vertex of the gate is 1.5 meters below the surface of the tank. So it's clearly mentioned this height is also 1.5 meters. Okay, so this height is also 1.5 meters. Fine. If this height is also 1.5 meters, then let us see what's happening. Then he is asking, this is an oil of specific gravity 0.8. So Sg of this oil, how much is this? This is 0.8, and density of water is also given. Density of water. This is density of water, and density of water is equal to 1000 kg per meter cube, and G is 9.81 meters per second square. Now, the hydrostatic force in kilonewtons exerted by the oil on the gate. Okay, so see here. So I think everything is going fine. Okay, so see here. This is 9.81 meters per second square. So total hydrostatic force. Look. Definitely, if you want to calculate the hydrostatic force, you need to know what is the location of centroid from the free surface, correct? So if this is your centroid, then ultimately this height. What about this height? Look, if this is your centroid, then this height, you know, this height is having some value. And what is this h bar measured from the free surface? H bar is equal to, look, this is 1.5 meters, and the base of the triangle is at a height of 1/3 from this, base, basically 1/3 of this height, correct? So total height of the triangle is 1.5 meters. So which means this value is 0.5 meters, correct? If this is 0.5 meters, then if this total length is 3 meters, and if the base is at a height of 0.5 meters from the base, so means if the centroid is at a height of 0.5 meters from the base, then definitely this h bar value is equal to 2.5 meters. Correct? This is 2.5 meters. Why it's 2.5 meters? Because this total value is 3 meters, and if this is 0.5 meters, then the distance between this free surface, if this is your free surface, then this free surface to this point, this height is 2.5 meters, correct? This is 2.5 meters. Then if you want the total hydrostatic force, F is equal to rho, density of the oil, because this is completely oil. Specific gravity is given, density of water is given. So if I want the density of oil, I can multiply the specific gravity with 1000, correct? So this is rho. G is asked to taken as 9.81 into area. Area of this triangle, half into base is 2 and height is 1.5, area into h bar. And what is the value of h bar? 2.5. So this is the total value in newtons, correct? So this is 800 into 9.81 into 2 gets cancelled, so no issue. 1.5 into 2.5. This is the total value in newtons, which you are getting in newtons. But what is the units they are asking you in? In kilonewtons. The hydrostatic force in kilonewtons. Okay. So if you want the answer in kilonewtons, first of all, let us find what is the answer in newtons. So if you want to know what is the answer in newtons, 800 into 9.81 into, look, 9.81 into 1.5 into 2.5. 1.5 into 2.5. Okay, so this is the value 29,430. So if this is 29,430, then definitely in kilonewtons this is 29.43 kilonewtons. Okay, so 29.43 kilonewtons. You can see here even the official answer in GATE exam was given 29.392 something, 29.47 something. So 29.43 kilonewtons is the correct answer. So 29.43 is the correct answer in this case. Okay, so how 0.5 meters? Okay, basically if you are having any triangle, this centroid is at a height of h by 3. Okay, this is h by 3. Basically, if this is total h, height of the triangle, then this height of the centroid from the base is h by 3. Clear? So that's how 1.5 by 5, 1.5 by 3 is 0.5 meters. Clear, Suyanda? Fine. Okay, so shall we go for the next question? Shall we go for the next question? Are you all clear with this? So are you all clear with this? So shall we go for the next question? So please do type in the chat box. Are you all clear to so far? Okay, good. So let's go for this next question. Okay, in which of the following arrangement would the vertical force on the cylinder due to the water be maximum? So basically they are asking you what is the, in which configuration. Basically you see here there is a cylinder, and in this cylinder to the left there is completely water till the top or the tip of the cylinder, but on the right side there is only half. Here there is completely water onto the left side, but there is nothing on the right side, no fluid on the right side. And similarly here there is fluid on the left, right, but not on the left. Here this complete solid is immersed in the fluid. So now please tell me in which configuration you have the highest vertical force. In which configuration you have the highest vertical force? Look, Fv is nothing but weight of the fluid column above the above the surface, correct? But now if you see, because of this fluid, because of this surface getting immersed, there will be some fluid pressure in the vertical direction and also on this side. But out of these things, if you compare all these things, here if you see the complete fluid, the complete gate or the complete solid which is here is inside the fluid, correct? So definitely if you take Fv is equal to rho Gv, means the volume displaced, majority of the volume is displaced in the fluid because of this case, correct? In this case, the majority of the fluid is displaced by the solid. So definitely in this case, the vertical force has to be more, because Fv is nothing but rho G into V displaced. The net vertical force acting on a fluid is, acting on a solid in a fluid is equal to rho G into V displaced. And you see, majority volume of the fluid is displaced in this case because the solid is completely inside the fluid. So obviously, the maximum vertical force will be in this case, D. Okay. Fine. Clear? because majority of the means most of the fluid is displaced in this case as compared to 1, 2 and 3, I mean A, B, C cases. Okay, so that's the reason. Clear? That's it. It's as simple as that. It's a simple question, and of course it's a very old question. Civil engineering question 98. Next, let's go for the 7th question. The center of pressure of a liquid on a plane surface immersed vertically in a static body of liquid, immersed vertically in a static body of liquid, always lies below the centroid. Of course, it happens center of pressure of a liquid and it lies below the centroid of the surface. Because why it happens? Normally, you see, if this is the plate, if I take look, so if this is a plate which I am taking into the consideration, then definitely my centroid will be here, somewhere here. Okay, and this is centroid, and you know center of pressure will be somewhere here. Correct? Why this is happening? Because we know if you take the pressure variation, fine, look, the pressure increases linearly in an incompressible fluid, correct? Because it's given liquid, so generally liquids are incompressible in nature, so we treat this liquid as an incompressible fluid. So if you see, our pressure variation is something like this within this fluid, correct? Okay, so this is the pressure variation. So you know, obviously whenever pressure is varying linearly with respect to depth, your total force assumed will act at some different location than when compared to the centroid. And I told you clearly, if this is your h bar, let me extend this a bit. So I want to show you some more things. This is your h bar and this will be your hp star. Okay, so h bar will be, means basically this h bar distance will be less than this hp star. This is what we have also seen. And why this is happening? Because as you keep on increasing the depth, your pressure force increases, correct? So obviously in liquids the pressure acting is same in all the directions, but of course in static fluids that's true, but that's not the reason why center of pressure always lies below this. There is no shear stress in liquids at test, correct? But that's not a correct reason why this for the location of this force F a bit below this centroid, the liquid pressure is constant over depth. No, this statement is completely wrong, because you know the liquid pressure is not constant and it varies something linearly with depth. And as you see, if the pressure is linearly varying, then this force, if there is some different case, like you know, if this is the plate and if the pressure is equal at all points, then definitely this total pressure force can be added effectively at this centroid. But here that's not the case. Okay, your pressure is changing linearly, so definitely your pressure force will lie a bit below this centroid, correct? This is what we have seen. D is the correct answer. Yes. Okay, so let's go for the next question quickly. Okay, this is the question. Civil engineering, again 96, a bit old question. A vertical triangular plate area submerged in water with one side in the free surface, vertex downward and latitude h, means basically the height of the triangle is h. Okay, has the pressure center below the free surface by, in yesterday's class we have done this question, correct? And the answer is h by 2. So let us once again do this question. Okay, so see here, if this is your free surface of water, so this triangle is, look, this is the triangle, it's given in this fashion and it's clearly given, you know, yes, so it's clearly given, yes, so this is how the triangle is located, correct? A vertical triangular plane area submerged in water with one side in the free surface, so one side is in the free surface and vertex downward. Of course the vertex of the triangle is downward and latitude h, so basically this height, I'm sorry, yes, so basically this height is h. Okay, so this height is h. Then if this height, I think I have drawn a bit excess, so let me take the help of some drawing tool. Okay, fine. This is still here. Okay, so this is H. Okay. Oh, I think something has happened. Fine. Oh, question has left. Okay, fine. Let me, I think something has happened. So let me draw this again. So if I am taking this as the free surface of water, then whenever I am having a triangle with its fine. So see here, if this is the triangle which is here, then when this height is H till this location, then they are asking for the depth of center of pressure. You know this value is, or this height is H by 3 in general. Let me as this. Okay, so this height is H by 3. So if this is the centroid, then you have some axis which is passing through the centroid, correct? So this is the axis which is passing through the centroid. So this is x, x. Now this is vertical. So if you want to calculate your center of pressure, which we have calculated yesterday, but of course, since some of you didn't attend yesterday's class, I want to repeat this. So see here, this height is H by 3. This height is H by 3. Okay, so H by 3 plus IgG. If this is the centroid C, then if this is the centroid C, moment of inertia of this triangle, if this base is B, for the time being, if this base is B, then if this height is H, then you know the moment of inertia of this complete triangular figure about this axis XX is BH cube by 36 into this is vertically immersed, so theta is 90, so 1 sin square theta is 90 divided by area half into base into height into H bar. And what is the value of that H bar, which is H by 3. This is what you have in total, correct? So if you simplify this expression a bit, we have, let us cancel few things. B can get cancelled, H and this H cube can get cancelled once, which is H, 2, 3 gets cancelled here, and this is 6. So H by 3 plus H by 6. So this can be written as 3H by 6, which is H by 2. Okay, this is the same thing that we have done yesterday, and this is H by 2 is the correct answer in this case. Clear? Yes, D, H by 2 is the correct answer. Very good. Let's go for the next question. So there is one more question, so please try to solve this. This is a question from civil engineering again. The force per unit width of the rectangular door submerged in a liquid of density rho shown in the figure. Look, this is of 1 meter, so definitely the centroid will be at a location of 1 by 2 meters. So if this is 1 by 2 meters, means 0.5 meters in general. So if this is 0.5 meters, then what could be this vertical height? What could be this vertical height? Let us suppose if this height is something like this. So if this is 45 degrees, then if this is 0.5, this will be 0.5 divided by sin 45. Correct? So this is 0.5 divided by sin 45, and this is H bar. So if you want to know the complete force per unit width, F is equal to rho G into area. What is this area? This complete plane length is 1 meter and width, it's given unit width. So if this is unit width, then this plate is to a thickness of 1 meter outside this board. So this is 1 into H bar. So what is this H bar? 0.5 divided by sin 45. So 0.5 divided by sin 45 value is 1 by root 2. Correct? This is what we have. So F is equal to rho G into this 0.5 can be written as 1 by 2 divided by 1 by root 2. Okay, so if this is the case that we have, so now this will get cancelled, and if this is root 2, then F is equal to rho G divided by root 2. This is the force on this plate by unit width, which you can see rho G divided by, I think we missed 1 2 here somewhere. So they are asking the force per unit width on the rectangular plate, rectangular door, of course, submerged in a liquid. So density into this into gravity into 1 into if this is 0.5, then definitely this height could be, this is 0.5 into sin 45, correct? I'm sorry, because this is opposite side, so this is 0.5 into sin 45. Okay, so 0.5 into sin 45 degrees, a basic trigonometry. So if this is 0.5 meters and if this is 45 degrees, then this height, if this is 45 degrees, then this will be sin 45 degrees into this 0.5. Okay, so this is 0.5 into sine 45. So let us you do the calculations here. 0.5 into sine 45. So let us reframe this calculation. So see here, this is 0.5 into sine 45, which is 1 by root 2. Okay, so 0.5 is nothing but 1 by 2, and into root 2 will give you 1 by 2 root 2, and rho g divided by 2 root 2. This is what you have. Okay, rho g divided by 2 root 2. This is what we have, and it's in option C. Okay, so rho g divided by 2 root 2. Correct? It's a simple question, so C is the correct answer. Clear? Just a second. I think there is some error in the class. You couldn't see the video. Yes. So OG by 2 root 2 is the correct answer. So yes. So can you all see this? Can you all see the screen clearly now? Okay. Yeah, I think streaming is going fine. Oh, well, just a second. Is there any this thing? Okay, fine. Now we can see this. Very good. Next, let's go for one more question. An open tank of 2 meter, 2 meter, 2 meter is filled. Of course, 2 meter by 2 meter by 2 meter is filled with layers of two fluids. Good question. This is the next question. Is filled with layers of two fluids. Okay. Depth of each layer is 1 meter. The top layer is that of an oil. So top layer is that of an oil of specific gravity 0.8. The bottom layer is water. Consider the density of water. Density of water is equal to 1000 kg per meter cube, and acceleration due to gravity is g is 9.8 meters per second square. Neglecting the effect of atmospheric pressure. This sentence had to be made a note. Neglecting the effect of atmospheric pressure, the force exerted by the fluid on one side of the sides of the wall. Okay, so see here. This is a good question. Look, basically there is some tank, some square tank, of course. So see here, there is one more diagram that we can plot actually. So see here. Look, so if this is what we have, okay, so this is the tank of width 2 meters. Okay, so what happened inside this? There is now fluid. Inside now we have fluid now, and there is some 2 layers of fluid till the height or till the depth of 1 meter. Like for example, if you see, let us try to show you. So if this is the mid height of the plane. Okay, so see here. So below this plane there is some water, and above this plane there is some oil of specific gravity. Here we have water, and here we have oil on the top. Okay, means the top layer is 1 meter height. So you can write this layer is 1 meter, and this is also 1 meter. Now definitely if you take this face of the if you take this face of this surface, look, if you take this face, for example, so I'm sorry. So basically this is the face which I am trying to talk about. Okay, so this is the face. So if this is the face, if I am taking, because this is the vertical face, now what is the pressure exerted by this fluid on this face? Look, now if I draw this face like this, then definitely, of course, it has some width of 2 meters. This is 2 meters again. So this is so this is 2 meters. So if this is 2 meters, then this is the vertical face, and the depth into this is 2 meters. Now on this fluid, on this we have oil till 1 meter. So this is some oil whose density is a bit less comparatively. Okay, so this is oil, and this height is 1 meter. Okay, so this height is 1 meter, and we have water for the next part. We have water here. Look, this is 1 meter. Okay, so this is 1 meter. Fine. Now, what is the total pressure force acting on this surface because of these two fluids? Correct. Now, this, if this is 1 meter, the centroid of this lies here, and the centroid of this portion also lies here. So this height is 1/2 meters, and this is at some different height. Let us see here. If I want to write the force exerted by the oil on this surface, look, this much portion is in contact with the surface, correct? So the force because of this oil at this plate is equal to density of oil into G into what is the area of the plate that is in contact with oil. Look, initially 1 meter depth is filled with oil. So 1 meter into the thickness of the plate is 2 meters. So 1 into 2 into h bar. This h bar is 1/2. So this is density of oil is given. It's 800. Somewhere it's mentioned. Yes, the specific gravity is 0.8. So definitely the density of oil is 800 into acceleration due to gravity is 9.8. So 9.8 into this 2 gets cancelled. So this is 1. So 800 into 9.8 newtons. Let us suppose if you are writing in newtons. So 800 into 9.8. 800 into 9.8. This is what we had, 7840. Okay, so total 7840 newtons is the force exerted by the oil. Next, if you talk about force exerted by the water, because water is also exerting some force. Now, here one thing, you can't directly write OGA into this distance. Why? Because I told you whenever there is some surface which is involved in water, then you can suppose to write OGAH bar only if this free surface, only if this surface is at atmospheric pressure, correct? Only if this surface is at atmospheric pressure, then you can write this H bar measured from this free surface. But now, if you see the pressure at this interface, the pressure at this interface is not atmospheric pressure. There is some pressure because of this height of this oil column, correct? So what is the pressure at this location? P is equal to rho oil into G into 1, of course, because this oil is at a height of 1 meter. So if you convert this oil head into water head, then density of oil into G into 1. This will be equal to density of water into G into height of this water head above this. I told you clearly, whenever there is some pressure P1 which is not equal to this, then please write P1 is equal to OGH and calculate height of the water column or height of the same fluid above this as P1 by OG, correct? So if you do this, this is the analysis that you get. So H is equal to O oil, GG gets cancelled, divided by O water, which is specific gravity of oil. This is 0.8. So which means the static pressure force exerted by this water on this gate or on this portion of this wall is equal to, look carefully, is equal to, let us suppose if you are constructing an excess column of 0.8 meters of water, okay, this is imaginary water, and now if you measure this center from this level, then definitely your calculations are again correct, because you remember this logic. So that's the reason why we are doing this. So density of water, which is 10 cube or 1000 into G is 9.8 into area of the plate which is in contact with water. You know, this is the area of the plate which is in actual contact with water. So 1 into the width of the plate into the plane is 2 meters into the height or this h bar measured from the free surface, assumed free surface of the water. This is how much? Look, this is 0.8 meters and this height is 0.5. So 0.8 plus 0.5, total you have 1.3. Okay, so if this is 1.3, then this is equal to, what's the total value in newtons? What's the total value in newtons? 1000 into 9.8 into 2 into 1.3 is 2.6. So 2.6 into 9.8, 2.6 into 9.8 into 1000. So this is the value, 25,480. 25,480 newtons. Okay, fine. This is the value, 25,480, of course. So did you all understand this? Did you all understand why I am creating an excess imaginary fluid column of height h? Are you all clear with this? If you are clear, please do type in the chat box. So are you all clear with this? Why we are creating an excess fluid column of height h? Because this surface of water is not at atmospheric pressure, it's at some pressure because of this oil column. So we need to create an excess fluid column, means in actual case an excess water column which is of height or which creates a pressure equivalent to this water oil column height. So are you all clear till this point? Once explain about h is equal to 0.8. Okay, fine. Normally there is water here. Look, this is the interface which I am drawing here. Okay, there is some water interface here and there is some plate of length 1 meters, of height 1 meter here. But now we can directly calculate this as h bar only if this pressure is P atmosphere. But in this case, when P is not P ATM, I told you should develop a fluid column of height h, which is equal to P1 by OG, which means we need to create an excess fluid column of height h here. Correct? So, and we need to measure this distance from this location. This is your h bar now in this case. Okay. So, if this is your h bar, then we get 25,480. So, what is the total force? F total is equal to F oil plus F water. F water. And what is the value? 25,480, which you are having here, 25,480 plus 7840 plus just a second, plus 7840. So if you calculate this value, you get 33,320 newtons. So 33,320 newtons. Okay, so this is the total force in newtons exerted by this fluids combination on that wall. Clear? 33,000 to 33,500 something is given. That's okay. So 33,320 newtons is the correct answer. Okay. So are you all clear with this? Because numerical answer questions, they have some range. So definitely this is the case. Okay. Fine. So did you get some idea on how to solve these questions? Clear? Okay. So I think there are some 2-3 more questions that are left, but of course time is a bit short. So, and anyhow, those are simple questions a bit. I would like to discuss this question as the last question for today, because this is a bit interesting question. So let us see this vertical force again, Fv. Basically they are asking you, there is one sector at which this free surface is free surface of water is somewhere here. Then they are asking you what is the net vertical force, and of course they have given some thickness of this gate on the water per unit depth perpendicular to the plane of figure. Okay, so this gate, look, this is the gate which is here, which is shown by them. Correct? If this is the gate which is shown by them, this gate is of width 1 meter into the plane of the paper. So if this is 1 meter width, and if the fluid is still this particular point, then what is the vertical force? Basically this area which is displaced by this gate completely. Correct? This area which is displaced by this gate, this area into depth of this gate into OG. This is the total weight, OG into area. If this, I am calling this as area A, then OGA into depth. They have given unit depth. So this is the basically basically this what is this? This is basically the total vertical force on this gate. Correct? So now what is this area? That is our main point of interest. Look, how to calculate this area. This is 2 theta and this is arc of a cycle. It's clearly given. It's a form of a circular segment. So if this is segment of a cycle, means if this is some part of a circle, then this complete area of the sector means the area of these two triangles plus this complete shaded region, which is equal to 2 theta by pi r square. Correct? 2 theta by 2 theta by 2 pi. 2 theta by 2 pi into pi r square. This is what the complete area of this complete section. Correct? Because means this complete area. If you see this complete area which we are drawing here, this complete area is 2 theta by 2 pi into pi r square. But now from this area we need to subtract the area of these two triangles if you want to get this area. Correct? So if you want to subtract the area of these two triangles, look, this is r, this hypotenuse is r because this is a circular gate of radius r, and if this is theta, then definitely this is r cos theta and this height is r sin theta. Same is the case here. This is r cos theta and this height is r sin theta. So this is a triangle. So you can see this is the triangle whose base is 2r sin theta, and of course this height is r cos theta. So what's the area of this complete triangle? Let me show you the complete triangle once, which I am talking. So this complete triangle, basically this complete triangle, what is the area of this complete triangle? Base half into base. Base is r sin theta plus r sin theta, total 2r sin theta into r cos theta, which is height of the triangle. Correct? So r cos theta. So 2 gets cancelled. So basically if you subtract this value r square sin theta cos theta from this theta by pi gets cancelled, theta r square, then you will get the area of the shaded part. Correct? So if you apply this rho g into, and of course there is 1 into, let me write area first. So what is this area? Theta into r square minus this value, which is r square sin theta cos theta. R square sin theta cos theta into 1. This is what we have. Correct? So this is equal to rho g. If you take out r square out, we have theta minus sin theta cos theta, and the sin theta cos theta can be written as sin 2 theta by 2. Correct? So sin 2 theta by 2 into 1. This is what we get. So you can see the same thing, rho g r square into theta minus half sin 2 theta into g, because we have written a different combination. If you want to write, you can write the same combination. You can shift the g to the right side of the bracket, then you have rho r square into theta minus sin 2 theta by 2 into g. Clear? This is what, basically the net vertical force on this gate. So are you all clear? Fine? Okay? Okay then. Fine. So I think there are some 3 more questions, or maybe at maximum 4 questions, but those are a bit simple questions. So please try to solve that by your own. And for your information, there is one thing, because of other assignments which are much priority, we are standbying this project of fluid mechanics to a bit extent, to a little extent. Okay, means from tomorrow we are not having this fluid mechanics classes. We are taking a short break because of some other assignments which are which are needed to be done a bit quickly. So once those assignments are done, we'll again come back and continue this lectures on fluid mechanics. Okay, actually I need to start 4th module, buoyancy and flotation, tomorrow, but because of these assignments I'm not able to start immediately. We need some time, means basically some 2 weeks or maybe 3 weeks duration at least, so to finish off the other things which are a bit in need first. So once those are done, again we'll get back to the things. Okay, so please stay tuned to the Engineers Hub official channel. You can get all the updates about everything. Clear? So anyhow, as we have stated you that we have started offline batches. We have started 2 batches, one on 1st of March and second on 15th of March. Both are running successfully as of now. So the last batch which we are starting for this regular batch, means basically for the passed out, which are having a daily class for 5 hours from 2 p.m. to 7 p.m. for 5 to 6 months of time, for which the expected time of finishing is July end. So you can always join this batch, and we are going to start the last batch from 29th of March 2021. Okay, this is the last batch C which we are going to start, and of course I think my phone is switched off. Fine. Okay, it's a bit low charge. So always, if you can join Engineers Hub, you can always get the guidance of Negi sir from his GATE All India Rank 1 for 2019 and 20 XC papers, and also along with his he has some nice team, so you can get the guidance of his team as well. Okay, so this 5 to 6 months program will be running, and of course this class is for 2 p.m. to 7 p.m. every day. Okay, so totally we'll be having 5 hours of effective class every day, and this batch goes for 5 to 6 months again. So here we'll be covering each and every topic in very detail. So if you would like to join us, you can definitely find your seat by dialing to any one of these official contacts of Engineers Hub. Okay, you can contact to this number or else to any of the official contact numbers that you find. This is the official landline number of Engineers Hub. So you can call to any one of these numbers and you can talk about your admission details. Okay, and always you can get the official updates of the content at the Engineers Hub channel, and you can always find much content that's of use to you on the official channel of Engineers Hub, YouTube channel of Engineers Hub, and also you can get these notes of class on daily basis on these Telegram channels, basically Engineers Hub /ME, -ME, Engineers Hub ECE /ECE/CE CSE and all others. So you can get notes in any of these 2 channels always. Okay, and always you can find the official updates of Engineers Hub on its Twitter handle, Facebook page, LinkedIn profile, and also on the official website engineers-hub.com. Okay, so you can always find some important content related to this courses, updates, and all on this different platforms of Engineers Hub. So I hope you enjoyed this first session of lectures for the first 3 modules, fluid and its properties, fluid statics and hydrostatic forces. So actually because of this assignments, we need to delay these lectures a bit. So after some 3 weeks or some other time, we'll definitely continue this series on fluid mechanics. Okay, till then this project of fluid mechanics will be on standby, and for the time being, let's stop this series here. Thank you all. Have a nice time. I hope you enjoyed the lectures. Thank you all. Good night.